Hello everyone and welcome to the second video of the Solow model. I'm gonna just basically continue from the last video, so if you didn't watch that one, I recommend you go back and watch that one before this one. So we are in a steady state situation, but we are only looking at the GDP growth, and we want to look at the GDP per capita growth. So the only thing we will have to do is basically rename the axis here, and let's call y, let's account for the laborers or the people in this economy, and we'll do the same thing with k. Now what happens to the depreciation is that not only do you have to invest back in new capital that depreciates, but you also have to invest in or equip the new people that just moved into the economy. So we have to save more now or invest more. So we will put the new people in here times k. And so this line is going to be steeper. It's going to be n plus delta times k. So the steady state is going to move from here all the way down here, right? Where the savings line crosses the depreciation, or the new depreciation line, if you want. And if we look at the GDP per capita, the GDP growth per capita, well, then it's not going to grow at the rate of n anymore, n plus a. It's going to just grow at the rate of a. So what do we have here? Well, this is the most important message that Solow had, is that GDP per capita grows at the rate of technology. So technology is basically the driving force behind economic growth. Of course, we can talk about, economies growing bigger with immigration, and big countries have huge economies, but if we're accounting for people, the only growth we see is actually the technological growth, right? So we can also go one step further and just account for technology here also. We just put a in here everywhere, and we account for a up here in the steady state also. Actually, this is getting kind of messy, so I'm just gonna try to get rid of all of these lines here. Oops, I just deleted the production function. Let's never do that. Okay, like this. Okay. Alright, so I'm just gonna draw a new line here which says a plus n plus delta times k. Now the picture looks the same way. We have a steady state in here, but the message is that if you account for technology, we have GDP growth per efficient capita, and that growth is gonna be 0, right? So this is just another way to describe a more I don't know, a more realistic situation. But the main message and the most important thing is that technology is what drives growth in the real world. And this brings me to my last point, which is the so-called Solow residual, which is basically technology, and that's what Solow called technology. And why did he do that? Well, it's interesting because wouldn't you want to measure technology and the rate at which technology grows? Well, you would, but it's kind of hard, isn't it? How would you even measure if someone had a huge idea that would change everything? How would you measure that in numbers? And economists love numbers. So Solow had a smart way of doing this, because if you think about it, what did Solow do? Well, he just divided growth into different parts. So labor growth, capital growth, and technological growth. So let's write it like that, and let's say, for example, that the GDP growth was 2% or something. So the economy grew at 2%. This is just, the triangle here is just change, and then if you divide that by the output itself, you have a percentage change. Okay, so the change in output is equal to the change in technology, as we have seen, right? Plus some change in labor, Now, this gamma here is only the part of the income that stems from labor. So we're gonna take the rest of the part and we're gonna attribute that to capital. So the capital change. So let's say we know, or I mean, it's plausible to assume that we know a lot about the labor market, and we can actually observe this part here. We can see that maybe the labor has grown by, I don't know, 0.5% or something. And same goes for capital. Of course, we can measure how much capital we have. So let's say we also have 0.5% of that. Now, we can see that regardless of how difficult it is to measure this, we know what it is because these two add up to 1% and this is 2%. So this must be 1%. So this is why it's called the Solow residual. You can measure technology by just turning the equation around and measure the residual in the equation. And this is how Solow have done it, and this is how we can actually observe technological change and growth patterns in the real world today. So that was what I had to say about the Solow model. I hope I could help you a little bit. I know it could seem a little bit difficult and strange with all the graphs that change when you change the, or rather don't change when you change the y-axis and k-axis. But it's just a way of telling you that technology is the most important factor when talking about real growth when you account for population growth. So thank you very much for listening. Just leave a comment if you have a question or something. I'll be happy to help you. Thank you very much.